Hello everyone. Let's start a new question. Discuss a Khosala's method of independent variable to design a weir. Let's see a independent variable method. This figure shows some specific case only. In actual practice, we may have a number of piles at upstream side or downstream side, and intermediate points, and the floor also have some thickness. Khosala solved this actual problem by empirical methods known as a method of independent variable. This method consists of dividing a complex profiles into a number of simple profiles as shown in a figure each of each of which is independently uh, amenable to mathematical treatments and then applying to corrections due to the mutual interference of piles and due to thickness and slope of floor. Thus, the analysis of floor is complex profile shows in figure 4.16 can be broken into the following simple profiles and a pressure and the key points are obtained. First, 2 and 3. First is a straight floor negligible thickness with a pile at upstream end. This is a 4 straight floor of negligible thickness with pile at upstream end. Second is a straight floor of negligible thickness pipe at intermediate point. And third is a straight floor of negligible thickness at with pile at with a pile at downstream end. The pressure obtained at key points EDC are corrected from the following. First is a correction for thickness of floor, second is a correction of mutual interference of the pile, and third is a correction due to the sloping floor. Now first correction of thickness of floor. The pressure are calculated at key points considering floor of negligible thickness. Example, at the top level of the floor, but point E1 and C1, top level of the floor, point E1 and C1 are at the bottom of the floor. Thus, pressure at the actual point E1 and C1s are computed by considering linear variations of pressure between point D and the hypothetical point E and point C. When a pile is at upstream side, and the correction for it is what we call C1. C1 is equal to phi D minus phi C by D1 into T1, which is additive. Pressure at point C1, here pressure at point C1 is equal to phi C1 is equal to phi C plus phi D minus phi C by D1 into T1, where T1 is a floor thickness, D1 is a depth of upstream pile. This is a D1 is a pile upstream depth of upstream pile. Now, when pile is at intermediate point, so correction for E1 and C1 we have to find. So for E1, phi E minus phi D by D into T, which is subtractive, and correction for C1 is equal to phi D minus phi C by D into T, which is additive. The phi E1 is equal to phi E minus minus phi D by D into T, where phi C1 is equal to phi C plus phi D minus phi C by D into T, while pile is at downstream end where correction is even. So E1 minus ED phi E minus phi D divided by D2 into T2, which is subtractive. First one was upstream side was additive. So phi E1 is equal to phi E minus phi E minus phi D divided by D2 into T1. Correction for mutual interference of the pile. If there is a mutual interference in between the piles, the correction C is given by C is equal to 90 under root D by B dash in bracket D plus small d plus capital D divided by B, where C is the percentage correction to applied to pressure heads. B1 is the distance between the piles. B dash, sorry, B1, there is a not B1. B dash is a distance between the pile. B is the total length of impervious floor up to here, upstream side to downstream side. D is the depth of pile on which the effect of the another pile of the length D is required to be constant. So this is the depth D, and capital D is the depth of the pile whose effect is required to determine on neighboring piles. So here and here we have to find out. The correction is positive for point in rear or backward, and subjective for points forward and direction of the flow. For example, if we want to find a interference point, interference of pile 2 or pile 1, the correction will be positive since the point C of the pile 1 and rear with respect to direction of the flow. This is because due to the pile 2 there will be heading up of pressure at all the points to its upstream sides. Similarly, if correction is to be determined at point E for pile 2 due to the interference of the pile 1, the correction is subtractive since E of point E of the pile 2 is forwarded in the direction of the flow. So pile 2 will be interfere with the downstream phase of the pile 1 and upstream phase of pile 3. Similarly, pile 1 will be interfere upstream side phase of the pile, and there will be no interference of the pile 1 on downstream phase of the pile 2 on the pile 3. Third is the correction for slope. The pressure calculated in here at various key points E, D, and C are considering floor as a horizontal, but the pressure below the sloping floor may be greater or less than the horizontal floor. Hence, the correction is plus the down slopes and minus for up slopes. Following the direction of the flow, the correction for the various slopes are given. Okay, so go through these three corrections, and this is about the independent variable of design of weir.